pay attention. Okay, let me
Ma'am,
share the screen. Yeah, who is speaking?
Ramya ma'am.
Yeah, Ramya, go ahead.
The session is not on recording.
I have put on record now. Thank you.
Yes,
Just
ma'am.
now started. Thank you. Okay, let me share the screen and let me go to the PPT first. Then I will take the programs for you. Okay. Um, okay. The topic speaks about concurrency. Can anybody quickly comment what is concurrency? Quickly comment. What is concurrency? Simple English word. What is concurrency? Can anybody? No? Okay. Um, uh, See, concurrency speaks about parallelism. Okay, when I want to talk about, see, this parallelism can be dealt in two manners. One way is I have a resource which is shared among multiple people. I have one dabba, okay, tiffin dabba, that is shared by three people. All three people are eating from the same dabba. But you just imagine the dabba's opening mouth is this much small and all three are putting hands in it. Definitely none of us will be able to eat. Okay, the concurrency speaks something like this. There is a resource which is shared among multiple people, those multiple people, shit, this waiting, it is eating my head. 1 minute. Okay, so when I have a shared resource, anything that is shared among multiple people, that shared thing is something like that. It can be handled in two ways. One way is I will make sure that the three people who are sharing that particular resource, all the three people will come to a conclusion that, okay, I will go first, then you go, something like that. Or the person who is more hungry, that person can go and eat first. Then the secondly hungry person can go and eat. Then the thirdly hungry person. If all the three are equally hungry, now what will happen? Now they have to take a decision. Okay, I will eat one first, then you eat the second, then third. So we will go in the cyclic manner. This kind of resource sharing, whenever is there is a sharing of resource. We talk about what is called as concurrency. Okay, on the shared resource, when we are talking about multiple people acting at a time, that kind of situation is called as concurrency. Parallelly, people are working on a single shared resource. Now, how these people can think about how I can share this resource which is available to me, that is decided by multiple ways. So Java has a special package for this, that is called as utility package. It is called as utility package. Any example which talks about any other utility package? Scanner, date. Okay, so among those utility packages, there is something called as concurrent utility package. Okay, it comes under the concurrency. So you can see, you have seen before also how you can go ahead with the concurrency. We have seen simple threading example which talks about synchronization, simple inter-thread communication, simple synchronized keyword. All those things are very basic or very minute way of achieving concurrency. Okay, but if I have some higher level of achieving concurrency like thread pool management, if I want semaphores, if I want management of the whole of the Java compiler, in that case I require an extensive concurrency, not the minute level concurrency. Then these concurrency utilities are being upgraded from JDK 7. But up till that, we had very minute things like inter-thread communication, synchronized keyword, okay, fork exec. So all the fork, join, all those things were taken care in the basics of Java. But now, since I require extensive utilization of concurrency, I have something called as concurrency utilities package. There is an extra package added in the utilities. Okay. So that is called as concurrent Java package. It is available in the package named java.util.concurrent package. In that, there are two sub packages. One talks about atomic, another talks about locks. How these are different? Atomic, whenever you talk about in atomic, it is individualistic. Okay. It tells that, see, until this timeline, this is mutual exclusion, guys. This is called mutual exclusion. Until this timeline is there, I am the owner of that. I am the owner of that. That is called as atomic. At a time, one person is there who will take the critical section. Who will take the critical section? I'm using the word critical section because it is operating system word I'm using. Okay. The person who is acting on the critical section or the resource, that particular resource is owned by only one person at that moment. That is called as atomic. That is also a concurrency. Exclusive atomic concurrency it is. But there is something else where multiple people are there. If I go ahead with this kind of atomic nature, I will not go for what is called as parallelism. I want to have a pseudo parallelism where looks parallel, but there is a minute difference between acquiring the critical section and leaving the concurrent section. Okay, that is governed by what is called as locks. So concurrent package has two ways in which I can manage. One is atomic nature and another is lock. Atomic nature talks about one person taking over the resource as a whole. It doesn't allow any other person to enter. Locks talk about, look, I have a resource. That resource we will share among ourselves. Whoever wants to use, acquire the lock. Once you are done with the usage of that resource, release the lock. That lock will be acquired by second person. See, again, that second person is decided by many algorithms, whether it is FIFO, whether it is round robin, many other algorithms are there. So this is called lock acquiring releasing. Okay. So among these two, most preferred is usage of locks. Usage of locks. So the same thing has been spoken out in the coming slides. Okay, whatever I have spoken now. So when I talked about simple synchronization and inter-thread communication, that was already there. Other than that, there were many more features added. What are those? They are termed as synchronizers, executors, concurrent collections, fork join framework. Among them, we will be talking about for now what is called as synchronizers. Okay. For your IA, please concentrate on synchronizers alone. Alone. Okay. I hope I'm clear with this. All these will be dealt with in the further classes. So now, under the concurrent package, I will be going ahead with the following features. What are they? Synchronizers. There is something called executors. There is something called concurrent collections. There is something called fork join framework. Out of these four, I will be speaking about only the synchronizers for now. The rest three, we will be speaking about it in the later classes. Okay. Don't see the other three. Now, I have spoken about it already. Okay, I will just skip these slides. Now, among these synchronizers, when I speak about the concurrent package, it has the first very important feature that is called as synchronizer. What is this synchronizer speaking about? When I talk about high level way of synchronizing, see, ITC and all are low level synchronization using synchronized keyword. That is also a low level synchronization that is supported at the thread level. Okay. And remember, all these categories, whatever I'm speaking, they are also thread safe. When I tell thread safe, they are following threading, multi-threading. Okay. Now, these synchronizers can be implemented in 5 different ways. These are implemented in 5 different ways. See, don't get confused. I have concurrency utilities. Among concurrency utilities, I have very basic concurrency utilities like inter-thread communication, synchronized keyword. Okay. The second is extensive concurrencies. In that extensive concurrency, we have something called as java.util.concurrent. This concurrent package has two sub packages, one called the atomic and the other called, can anybody comment? One called the atomic and the other called, can anybody quickly comment? Yes,
Lock.
Varshini. Yeah?
Locks.
Lock, correct. The other part is lock. So when I speak about atomic, individualistic, one person holds the whole of the resource until it completes. It just tells all others have to wait. This is mutual exclusion. The second talks about lock, where multiple people are working on the same shared resource, but they will come to a conclusion. Okay, we will follow this kind of ordering. There is no confusion at all. Okay, that is called as locking system. That second category is most important compared to atomic. Okay, atomic handling is very easy. At a time one person is there, but when I take up lock, the person who takes over the critical section or the shared resource will hold the lock, acquire the lock, and as soon as the work is completed, it releases the lock. Among doing these things, we have 5 different ways in which I can do the concurrency. Okay, those concurrencies are usage of what is called as semaphore. There is something called countdown latch. There is something called cyclic barrier. There is something called exchanger. There is something called phaser. Okay, how these are different from each other. When I take up semaphore, when I take up semaphore, there is a mentioning of explicit mentioning of how many people at a time are working on the shared resource. In semaphore, it tells that you tell me, other than you, how many more are there who are working on the shared resource. Accordingly, each of the person who is involved in the shared resource, each of the person will tell, I'm acquiring right now, I'm done with it, I'm releasing right now. So there are two functions associated with semaphore. Okay, one telling acquiring, another called releasing. When there is countdown latch, there is countdown latch. Here it talks about, okay, somebody has acquired this resource. Till what time you want to keep this? That time is decided by number of events that are being done on that particular shared resource. It means what? My dabba example I will take, then you will understand very easily. I am very hungry. What I will do is, I will tell others, I will take 5 bits from the dabba. Okay, until and unless I complete my 5 bits, all others have to wait. So 5 events I am telling. At the beginning only, the person who is holding the lock will tell that you have to wait for 5 events. So it expects in the countdown latch how long you will allow this person who has acquired the shared resource, how long you will allow. In terms of what? In terms of the number of events that occur on that shared resource. Okay, for example, if you are having a read write buffer, something like that, read write buffer, there is a single buffer. When you want to do apply read write buffer, you will tell that I'm writing 5 elements into that buffer. Until that time, you cannot start reading. Until that time, you cannot start reading. This is called countdown latch. So what it does, it fixes 5 as the startup. Once it writes, decrements the counter 4, 3, 2, 1, 0. When the counter becomes 0, the other person will take over. So it is based on the countdown. That's why it is called as countdown latch. Okay. Then there is something called as cyclic barrier. Okay. What it will do is, there is a group of people. Among the people available, there is a group of people. Subgroups are formed. Subgroups are formed. In each subgroup, there is a cyclic nature. There is a cyclic nature. That is round robin algorithm. Okay. There is something called a cyclic nature. In the cyclic manner, waiting time is there. There is explicit waiting time provided for this. Whenever there is a cyclic nature, Beyond that time, second person will take over. In that group, such multiple groups are there. Okay, such multiple groups are there. This is called cyclic barrier. What is a barrier? Waiting time. Waiting time is a barrier. Then there is something called as fourth one, which is called as exchanger. Here there is something like this. There are two threads working. The first thread sends a message to the second thread. I'm done with writing. There is an exchange of messages. Until and unless that message is received by the second thread will not begin. Okay, there is a mutual exchange of messages. This is called as exchanger. The last one, which talks about phaser, okay, which is something like this. See, there are 5 people who are printing the same document. See, all these are application specific. There are 5 people who are printing the same document to the same printer. When the first person gives for the printing, there is 100 pages of printing, assume. What they will decide among themselves, there are 5 people who are giving the printing option to the same printer. What they will decide among themselves, I will give 1 to 20. Next person will give 21 to 40 pages. Next will give 41 to 60 pages. So on until 100th page. So it means what? There is a phasing. There is a division of labor among the group of people who are working on the same shared resource. There is demarcation in the working. The way in which they are working, there is a clear demarcation. At a time you can do, but to the end user how it looks, all 100 pages are getting printed. But how long each thread is working? Only for 20 pages. This is called as phaser, where the whole of the process getting divided among 5 different threads. They will work phase by phase. Any doubt in this slide? Let me know quickly. Any doubt in this slide?
Good morning.
No, ma'am.
Yeah, good morning. Yeah.
Ma'am, in the cyclic barrier, you told groups and subgroups. Could you please elaborate on that?
Yeah, okay. Muhammad Usman, your doubt. I'll come back to you, Aditi. Usman,
No, ma'am, no doubt. I was just telling no, ma'am.
okay. Okay. So in the cyclic barrier, here what happens, there are, you just imagine like this, there are 10 threads available. Among these 10 threads, see, there may be a case like out of these 10 threads, 4 threads are working on reading. 6 threads are working on writing. Okay, you just imagine like this. These 4 threads which are working on reading, they will decide among themselves. They'll decide among themselves like what they will tell is, after the first write, I will read the first thread. Okay. After the second write, the second reader will have. In the writing phase, there is only one thread who is doing the writing. Okay, just imagine like this. There are 4 threads who are reading, or there is, there are 6 threads which are writing. You just imagine like this. Now, the first thread writes. The first thread writes. And this group, the first group, which is called as reading group, the second group is called as writing group. The reading group among themselves, they will decide that what we will do is, we will work in the random order, or we will work in the manner which is round robin. All 4 are doing the same task. Unlike in the phaser. In phaser, what happens? There is a difference in the working. But in the cyclic barrier, the group of threads are doing the same task. In the same task, they will have the division of labor. How the division of labor happens? In the cyclic manner, in the round robin manner. What they will decide? I will do the first reading and keep quiet. You do the second reading. You do the third reading and come back to me for the fourth reading. There is an association among themselves, but for the end user, it looks as if one thread is acting on reading. At, at the end user end, it looks as if there is one thread who is writing always. So that group of threads will act in such a way that they will not show it to the outside world that we are different. This is called group of thread working in the cyclic manner. Aditi.
Yes, ma'am. It's clear.
Okay.
Thank you.
Yeah. So any doubts in these five? They come under what is called as synchronizers, and they come under the package what is called as util.concurrent. I hope there are no doubts for now. I'll be taking each of these in detail. Okay. Shall I proceed?
Yes, ma'am.
Ma'am,
Yeah. So let me go ahead with what is called as semaphore. Okay. So now each one of these I'll be taking. Let me go ahead with semaphores. What is this semaphore? Okay, before I show that slide to you, operating system perspective, have you covered up this part, semaphores? Make comments quickly. Have you covered
yes,
this
ma'am.
part? Operating systems. Okay, what is this semaphore meaning? Can anybody comment? Yes? No? Okay.
Excuse me.
Okay, when I take up a semaphore, uh, when I explained it in the previous slide also, semaphore talks about acquiring the lock, releasing the lock. Okay, semaphore talks about acquiring the lock and releasing the lock. Guys, before I continue, in the data communication, have you come across different network topologies? There is something called star topology. There is something called uh,
Yes,
cyclic
ma'am.
topology. You have come across that?
Ma'am, actually, sir has not dealt with in that much details, but it is there, ma'am.
It is there. And
Yes,
there is something called as token ring topology.
yes, ma'am.
Yeah, there is something called
Yes,
as token. There is a small bit. It is actually a bit that tells locking system. That bit will be rotating among all the network components. So it is as good as one owner who releases the lock tells that this lock is available for you. Whoever holds this lock, that person will work. The other persons will sit back. According to the same topology manner, the semaphore also works. Okay. So let me go ahead with the semaphore. See, there is a shared resource and that shared resource has a controlling access. Please don't read the things that are being displayed in front of you. Okay. Please don't read. Just pay attention to what I am speaking. You can read this thing afterwards. I'll be putting it in your Google Classroom. Now, this all these concepts, they work on what is called a shared resource. Then only the problem will come. If there is no shared resource, there is no problem at all. There is no requirement of concurrency. Tell me, if I don't have a shared resource, parallelism can work so nicely. But when there is a dependency coming in, when there is a data consistency coming in, then only I have to have what is called as concurrency mechanisms. Otherwise, it is not required only. Multiple threads working on different data can work independently. They don't pose any kind of problem. This concurrency problem will come. These are called as problems actually. These concurrency problems will come only when I have sharing of the resource. Otherwise, no problem at all. Okay. Now, whenever I have a shared resource, that shared resource has an accessibility problem. Shared resource always has an accessibility problem. You just think like this. I'm the single teacher for both third sem as well as fifth sem. Okay. At the same time, can I teach data structure for third semester and advanced Java for fifth semester? I cannot. At the same time, can I take 7 semesters A and B division project review? I cannot. I have to have a demarcation. I have to have a locking mechanism. That locking mechanism speaks like this. What I will tell. Whenever I have my major project review going on, I will lock I will lock 7 semester people and release 3rd and 5th semester. I think this example will sounds better to understand the things that are going on. I am a shared resource. I am a shared resource. Who is locking on me? 7 semester people. When they complete their project review, among the 3rd and 5th semester, okay, both of you are free at a time. But am I the resource who can be available at both the places? I cannot. Then I have to think of, I have to lock somebody, I have to release somebody. I will release 3rd semester people and tell that 11:30 class I will take for 5th semester. That releasing 3rd semester people are free for somebody else now. Free for somebody else. So you just think like this. Think like this. Keeping this context into mind, just go through the things that I'm talking about. Okay. So what I will do now? What I will tell, see for me, on me, 3 people are there. What is the count available? 3 people are there. On me, how many? 3 people. At a time, all the 3 people can have the accessibility. I have a single classroom, Google Classroom. In that single Google Classroom, all 3 people's question paper I will be putting. All 3 are independently working. All 3 are independently working. Look at this scenario. Look at this scenario. When all 3 are working on the single shared person, but in this context, there is no problem at all in the shared resource because I am dividing them into phases. This is called phaser. I'm dividing them into phases. What is that? In my Google Classroom, I have accessibility to 3rd sem. I have accessibility to 5th sem. I have accessibility to 7th sem. All 3 can work parallelly. All 3 can work parallelly. This is called phasing. Okay. But when I take up semaphore talks about at a time how many people can have the control over the shared resource. For example, class I can take for only one. This is an instance where it talks about accessing the lock on the shared resource. How that accessing the lock will happen? There is something called as counter association. Whenever I set my priority to 5, if I tell 5 indicates 5th sem. When I set my priority to 3, it indicates 3rd sem. When I set my priority to 7, it indicates that I have to be there for 7th sem. At a time, one person. That one person has to acquire the lock. And how that person can acquire the lock? There is a counter associated with the lock. That counter can be made available to the person who wants to access the shared resource only if that counter is greater than 0. If that counter is greater than 0, see, this is a prerequisite for semaphore. That's why. Don't tell me why it has to be greater than 0. Semaphores are designed like that. Whenever you want to acquire the permission on the shared resource, the counter associated with that shared resource associated with you has to be greater than 0. Has to be greater than 0. And when you start using that resource, your counter becomes decrementing every time. Once it becomes 0, automatically the lock will go off. The lock from you will go off. Who will take over? The other person who is waiting. So there is a counter associated for every shared resource. That counter, if it is greater than 0, only then you can access. If it is equal to 0, you cannot access. Okay, so how this semaphores count is managed? This is managed by what is called as incrementer. There is something called as decrementer. This is called mutex. Okay, this is called mutex. So on this, I hope this basic terminologies are clear for you. Whenever the lock to be held is having a counter greater than 0, then only you can call a function acquire. Whenever counter becomes 0, you have to call a function which is release. Okay, acquire and release are the two functions which are useful in semaphores, and there is a counter associated on shared resource. Implementation of this I will show you immediately. Okay, now semaphore has two constructors. This is very important. Please just go through these things. sorry. Semaphore has two constructors. You can use the constructor in two ways. One is, I'm talking about one simple number you are passing. Okay, it is nothing but the number of persons who can act upon the same shared resource. If you don't give anything in this, it will be by default 1. At a time, number of persons who can act on this. Okay, so if the number is 1, only one thread can access that at a time. If you give 2, at a time 2 persons can act on it. If you give 3, 3 persons at a time can act on this. Okay, semaphores with the counter greater than 1 are better useful in phasor. Are better useful in phasor, where more than one thread are acting at a time on the shared resource. At a time. Okay, so semaphore count, it talks about the num that I'm passing. By default, initially it has to be 1. It has to be 1. The second way of using the semaphore constructor, you can pass num and then boolean how. This boolean how talks about if you give it true. If you give the second parameter of the semaphore as true. Okay, then it tells that I have to go on for calling the next thread among the waiting threads, for calling the next thread in the FIFO manner. What is that FIFO manner? The way in which they have entered and they have asked for the permission for the shared resource. In that order only, the accessing of the shared resource will be granted. Okay, so the second parameter is not so important. What is important for me? At a time, how many threads can act on the shared resource? That is more important. So most used is the first one. Most used is the first one. If in the second constructor, if you give the false in this, then the allotment of the next thread, incoming thread, will be random. Will be random. Okay, whether this is clear? Whether this is clear? So what I spoke about in semaphores is, I spoke about how the semaphores work. Semaphores work in acquiring and releasing the lock, and lock is always associated with a counter. If that counter is greater than 0, then only you can acquire. You can call acquire. If the counter is equal to 0, if it is equal to 0, you cannot acquire. It is as simple as that. And when you are starting with the semaphore can be associated with a number. That number indicates how many threads at a time can work on the shared resource. By default, it will be 1 for simplicity. Okay, I think I will proceed ahead. Now, when I spoke about the introduction of semaphore, I talked about two things. One is acquire, the other is release. How this acquire function is useful. See, the word acquire is associated with void. It always has interrupted exception. It always has interrupted exception, because the reason, before I can acquire the lock, other thread has to be interrupted. Always it will have interrupted exception. See, the thread which I am interrupting may have the high priority process, then it will throw exception. So always the acquiring is associated with interrupted exception. Okay. So whenever you are using this, you have to have throws interrupted exception. Whenever you have something like this, whenever you write acquire function, you have to put it in try catch block. Otherwise it will not work. So this is how you have to analyze writing the program. See, whenever there is given something like this, in the syntax of that function itself, it cannot work without writing try catch. This is how you have to analyze. So whenever you write acquire in any of the program, acquire has to be written within try catch block. Otherwise it will give error. So the first form talks about there are only one thread acting at a time. It assumes with like that. Whenever you write acquire, it is with the assumption that semaphore has given you only one permission. Okay. The second one talks about how many at a time can have the permission. How many at a time can have the permission. Okay. So this talks about number of threads at a time having the permission. Okay. Similarly, I will have two things in release. First release talks about only one thread is working that has to be released. Second talks about how many had acquired before. Those many number of threads have to be released. It works something like this. Any doubt till this point? Now we will go to, I think we will go to the program. Okay. Oh God. The meeting will be ending in 5 minutes. Please join back because I have to show the programs to you. As soon as it ends, please come back in 2 minutes. Okay. So this is the first ever example which talks about semaphore demonstration. Very quickly, I will move on to this. See, in this, I have taken two threads. One is called as increment thread, second called as decrement thread. And the name of the thread is A. The name of the thread in the second is decrement thread is B. Okay. Just have a look at this, how the semaphore constructor is called. Semaphore constructor is called with the count of 1. It means at a time only one thread can work on the shared resource. It creates an object which is sem. The same object has been passed to both increment thread and decrement thread. If you don't associate the thread classes with the semaphore, the demarcation, the proper concurrency will not be seen. I will show you that also by commenting. Okay. Now, I have the shared resource. Here I have taken a single shared resource which is count equal to 0. So one person is incrementing the count, another person is decrementing the count. On the same shared resource, the things are happening. Okay. So I have created a class for that, which is called as class shared. And it has a single member, which is count assigned to 0. One person, when it calls, it increments. Another person it calls, it decrements. It has to be static, only then the concurrency can be seen. Okay. Now, in the increment thread, I have used implements runnable. Here, the constructor, it is used for naming this thread. Okay. And then I have called the start. In the run method, I have simply, just have a look at this. I have simply talked about acquiring the semaphore. Acquire when I call a log getting acquired. Acquire when I call a log getting acquired. Okay. Then now once you have the permission to do that, what I will do, I will go on incrementing the counter. Shared dot count plus plus. What is this shared? What is this shared? The class shared has this count variable. So using that class, I have called the counter variable, and every time I will go on incrementing this count. How many times? 5 times. So count getting incremented. Count getting incremented. The same count which is 8 incremented is been printed. Nothing else I have done. Okay. Then I have called a sleep. If you want to call some other thread at this time, you can call. Now, when I've used acquire method, there has to be try catch block. This I have spoken about. Okay. Similarly, soon after you have done that, you have to release. Okay. What is this sem? Sem is the semaphore object that I have created. Next, I have the second thread, which is decrementing thread. So in the run method, I have to first acquire. I have to acquire the lock. Then what I will do? Accessing this shared lock, shared dot count minus minus. 5 times I will decrement. Okay, again this I have to put in try catch block. Then what I will do? I will release this. Okay, it's a very simple program. Let me run this program and show it to you. How this will work. Okay, starting A is waiting, A gets a permit, starting B. But by that time, A has started already incrementing. In between, B is waiting for the permit. Why it has come? Because I have called thread.sleep there. I have called sleep. So A's thread is waiting for sleeping for 10 seconds. During that time, B has printed this. Okay. Then 2, 3, 4, 5. A releases the permit. Then B gets a permit. Okay. So there is a decrement 4, 3, 2, 1, 0. Then at this moment, it has to release. It has to release. Okay. This kind of lock acquiring, releasing, it is called as semaphore. Okay. Now what I will do, I will just modify this program a bit. So what I will do is, I will just modify the program. I will remove these things. What is that? Wherever I have used a semaphore, no, that I will comment.